I'm Yueqilin. Here I'm going to show you the solution of question 2 in homework 8. Question 2 provided us the expression of n is a Poisson distribution with an parameter of lambda, and also defined a new stochastic process as x of t. And you're asked us to find out in question A, find out probability of xt equals 1. When the probability when xt equals 1 is equals p, probability of in 0 to t, and k is an odd number. That is because xt equals 1, in xt's expression we know when xt equals 1, the n is an odd number, that is this, and we can write into the sigma of k equals an odd number, and we put the expression of Poisson distribution into it. The t is from 0 to t, that is the probability can be write into this expression. To solve the sum of the expression, at first we need to write the e of e's lambda t's power into the Taylor expression is 1 plus lambda multiplied t plus lambda t squared divided by the factorial of 2, and plus the lambda t third power divided by the factorial of 3, and add that to infinity. Because this is the expression of e of e's lambda t's power, and what we need is is minus lambda's power, and we put the minus lambda in the t equals minus 1, we put into this expression, we can get the expression of e's minus lambda's power, and this is expression 1, this is expression 2. Use the first expression minus the second expression, we can get the e lambda t minus e minus lambda t will equals 2 multiply this expression, and we can get have a look at this the right side of the of this equation. We can find that what we need right now is the value of this expression. This is equal, so we can get the sum of the the sum of this expression when k is an odd number is equals 1 minus e minus 2 multiply lambda t divided by 2, and that is what we need to find out the possibility of xt equals 1. Now let's come to question B. Question B asks us to find out the expectation of x of t. To solve the expectation of the x of t, we need at first to solve the possibility that xt equals minus 1. Similarly, we need to get the possibility of xt equals -1. That is to find out the possibility of in 0 to t k equals even number. That is the sum of e minus lambda t multiply lambda t's k's power divided by the factorial of k. That can be write into this expression, and to get the value of this expression, we may think of the two equation of the we used in question A. That is the expression 1 and expression 2. Add these two equation, we can get the e lambda t plus e minus lambda t equals to 2 times 1 plus lambda t squared divided by the factorial of 2 and plus lambda t's fourth power divided by the factorial of 4 and so on. And divided each side by 2, we can get the value of what we need. And this expression equals 1 plus lambda minus 2 lambda t's power divided by 2. As a result, we can get an expectation of x of t will equals 1 multiply the possibility of xt equals 1 and plus the minus 1 multiply the possibility of xt equals -1 and put the value into the expression, we can get the final answer is minus 2 lambda t's power. Now let's come to question C. Question C asks us to find out the R of T1 and T2. At first we consider that when T2 is larger than T1, it can split into two situations. Is xt equals 1, that is 1 multiply 1, or -1 multiplies -1, and x of t can be -1, that is 1 multiply -1 or -1 multiply 1. So the R of T1 and T2 can be write into expectation of x of T1 multiply x of T2. That will equals 1 multiply possibility of x of T1 multiply x of T2 equals 1, and plus -1 multiply p possibility of x of T1 multiply x of T2 equals -1. And this can be write into the possibility of possibility of x of T1 multiply x of T2 equals 1 minus possibility of t of x and x of T1 and multiply x of T2 equals -1. And this is from the previous definition, we can know that this is the possibility of in T1, T2, and k equals even number, and this one is in the time of T1 to T2, k is an odd number, and so the expression can be write into this, and due to the expression of the Poisson distribution in this stochastic process, we can get that the value of the first expression is this one, and the value of the second expression is this one, and we got the final answer. And don't forget that this is the situation when T2 is larger than T1. and when T1 is larger than T2, and T1 and T2 can change the place. So at last we can get the final answer is R of T1 and T2 will equals is minus 2 multiply lambda multiply T1, the absolution of T1 minus T2. Yeah. Question D asks us to find is x of t is a WSS, and you explain the answer. From the previous definition, we need to know to judge is x of t is a WSS is to judge that is expectation of x of t plus tau multiply x of t, will it be a constant? We can write into this expectation into this expression, and finally we can get the answer is the expectation will equals is minus 2 multiply lambda multiply tau's power, and when tau is a constant, the value of expectation of this expression is a constant. That means the process x of t is a WSS.